In this video, I'm going to show you how to do AQA A-Level Maths, Paper 2, from June 2018, question 9. My name is Sunil Tanna. I'm a tutor and author. I live in Buckinghamshire, England, and I'm available for one-to-one tuition, both in person and online. A market trader notices that daily sales are dependent on two variables: the number of hours, T, after the stall opens, total sales X in pounds since the stall opened. The trader models the rate of sales as directly proportional to 8 minus T over X. After 2 hours, the rate of sales is £72 per hour, and total sales are £336. Show that X multiplied by dx dt is equal to 4032 times 8 minus T. Okay, so the rate of sales is dx dt, and we can see that dx dt is proportional to 8 minus T divided by X. So we can change this to being dx dt is equal to K times 8 minus T over X. Now we have some values that we can substitute in the equation. So we can sub T equals 2, dx dt is equal to 72, and X is equal to 336. So the equation becomes 72 is equal to 8 minus 2, or 6, divided by 336 times K. Now if you simplify that, it becomes 72 is equal to 6K over 336, and then multiply by 336 and divide by 6, you get K is equal to 4032. So therefore, dx dt is equal to 4032 times 8 minus T over X. And if we multiply both sides by X, we'll get X times dx dt is equal to 4032 times 8 minus T, which is the answer that we were looking for. Okay, next part of the question. Hence show that x squared is equal to 4032 t times 16 minus t. Okay, so if we go back to the previous part of the question, we had x times dx dt is equal to 4032 times 8 minus t. So if we multiply both sides by dt, we will get x dx is equal to 4032 times 8 minus t times dt, using separation of variables. That's permissible providing we integrate both sides, and since 4032 is a constant, I'll bring it out of the integral and write it like this. Integrating x becomes x squared over 2. Integrating the right-hand side will be 4032 times 8t minus t squared over 2. And there, of course, will be, since these are indefinite or constants, we'll have to put a plus c. But we can sub in the values that we used in the previous part of the question. We can sub in x is equal to 336 and t is equal to 2. Putting that in the left-hand side, we have 336 squared divided by 2, which is 56448. And on the right-hand side, we'll have 4032 times 8 times 2 minus 2 squared, which is 4 over 2 plus c. And you'll see it becomes out to 56448 is equal to 56448 plus c. So this tells you c is equal to 0. So now we know x squared over 2 is equal to 4032 times 8t minus t squared over 2. If we multiply both sides by 2 and bring the t out of the brackets, we'll have x squared is equal to 4032t times 16, we're timing 8 by 2 and bringing the t out of the brackets, minus t, because again, we're multiplying t squared by 2 and bringing the t out of the brackets, which is the result we wanted. Now, the next part of the question says the store opens at 9:30. The trader closes the store when the rate of sales falls below £24 per hour. So we could say at little t is equal to capital T, dx dt has to be less than or equal to 24, or in fact at that particular moment it'll be equal to 24. So let's maybe we'll say equal to 24. So if we substitute that again into the equation that we started with, which was x dx dt is equal to 4032 times 8 minus t. So we will get here x is equal to where is it? X times 24 dx dt is equal to 4032 8 minus capital T. And if we divide both sides by 24, we will get x is equal to 168 x squared x is equal to 168 8 minus t. And if we use the equation that we had from part B, which is x squared is equal to 4032 t and then 16 minus t, we can say that since we have, if we square this, then we will have x squared is equal to 168 squared, which is 28224 times 8 minus capital T squared, which gives us, but we also know that that's equal to the result we had in the previous part of the question, which is 4032 t 16 minus t. This is from part B of the question. And then what we can do is you can see we're going to, if we ignore the value x, we have a quadratic in t. So first thing I would do is divide out the 4032, which will, if you have 28224 divided by 4032 is actually 7. So you're going to have 7 times 8 minus capital T squared is equal to, if we expand that bracket here, we have 16t minus t squared. We can expand the bracket on the left-hand side, so that will be 7 times 64 minus 16t plus t squared is equal to 16t minus t squared. And you can now see it's a quadratic in capital T squared. Bring everything to the left-hand side. We've got 7t squared, add another t squared is 8t squared. We've got 7 times minus 16 is minus 112, and then take off another 16 is minus 128t, and then we've also got plus 7 times 64, which is 448 equals 0. And you could divide that one by 8 if you like. Everything divides by 8. So it'll be t squared minus 16t. 448 divided by 8 is 56. Unfortunately, there isn't an easy factorization for that. So you can use the quadratic equation. Hopefully you have a quadratic equation on your calculator. If not, you would have to use the formula with a is 1, b is minus 16, and c is equal to 56. And if you do that, you will get two answers, which are t is approximately 10.8284, or t is equal to 5.17. 16. Obviously, we want this is the earlier time, which is what we want. So we need to work out what 0.176 of an hour is. So we do 0.1716 times 60, and it comes to approximately 10 minutes. So we have, so 10.5716 is 5 hours, 10 minutes. So what we're going to have is 9:30 a.m. plus 5 hours, 10 minutes. So counting forward, it'll be 10, 11, 12, 1, 2, and then adding 10 minutes to 30 is 2:40 p.m. And that completes part C1 of the question. There's one remaining part of the question. Explain why the model used by the trader is not valid at 0930. So if you go right back to the beginning, we derived a differential equation, which was, we've used in several parts of the question, which was x dx dt is equal to k, which we eventually found was 4032 times 8 minus t, 4032 times 8 minus t. And if you remember, that originally came from saying that dx dt is equal to k, 4032 times 8 minus t over x. And of course, if at 9:30, x is equal to 0, so the denominator of this fraction is 0, so result is undefined. Is undefined, and model is valid. And that completes question 9.